Hello and welcome to our first ever episode of The Daily Planet. This is The Daily Planet for May 6th, 2018. I am your host, Dr. Pamela Gay. This is our first episode of a new weekday show here on Twitch. We are hoping that each Monday through Friday, CosmoQuest will be able to bring you a roundup of what's breaking in space news, what is new in astronomy, and what is going on in this universe that we all share. Thank you for all of you who are joining and flooding the chat. This is an amazing start to our show. Is it not May 7th? If it's not May 7th, I'm very confused and going to do a redo on the intro to the show. Today is May 7th. It really is. Okay, I'm still going to do a redo to the beginning of this show because we're going to record this and go out to YouTube. So no more confusing me, Phoenix. Okay. I'm sorry that there's multiple lags. Okay, let's try this again. Hello and welcome to the Daily Space for May 7th, 2018. I am your host, Dr. Pamela Gay. This is our first episode of a new weekday show here on Twitch. Each Monday through Friday, CosmoQuest is going to bring you a roundup of everything that's new in astronomy, space science, and going on with this universe that we all share. Let's begin with today's top story. First episode, still working out the bugs. So on Saturday at 4:05 a.m. Pacific, NASA launched the InSight mission. This little spacecraft is on its way to Mars, and its launch was perhaps best described as the launch no one saw. As it was described by Amy Sherr-Teitel, there were a number of news journalists out in the field, standing around, completely lost in the fog. And they heard a noise. They kind of felt a noise, but it wasn't the thunder that you're used to. And there was actually concern for a number of people for a few minutes that the mission had failed to get enough thrust from its Atlas V rocket to make it off the pad. It turns out fog is an amazing insulator of sound as well as of sight. So it was from above the cloud layer that a few lucky individuals were able to watch this launch. Other people, I see some of them out there in the feed, were actually in this horrible position where they were going to one of the public sites, they were following the directions, they arrived on time, but no one was in a particular hurry. And as they're walking along to the observation field, they kind of heard a rumble. And then people started reversing direction walking. So while this particular launch was enjoyed by few, Mission Control had a fabulous time because they could see the telemetry even if they couldn't see the spacecraft. We're hoping that a bad launch will lead to fabulous science to come. The Mars InSight mission is, on its way to Mars, and once it is there, it is going to do a number of things that we have never seen before. The first thing it's going to do is it's going to drop a heat flow probe, and that little heat flow probe is going to burrow itself down into the planet. For decades, we have been making estimates as a scientific community on how warm or not we think the soil beneath the surface on Mars might be. If it's warm enough, we have liquid water flowing beneath the surface. If it's too cold, we have ice embedded in the soils. Now, finally, we are going to have the data to answer this question and to help us understand, is it possible for life that relies on liquid water, the kinds of bacteria and small critters we find living under the soils of Earth, is it possible for that same small microscopic life to live beneath the soils on Mars? Now, we're not looking for moles, we're not looking for earthworms. Right now, all we're doing is measuring the temperature to see what is possible. Now, beyond burrowing several feet into Mars' surface and soils, we are also going to be deploying a seismic probe. And what this will enable us to do is, well, first of all, look for, if we have earthquakes on Earth, we have Mars quakes on Mars. And from looking at these Mars quakes, we can start to do two different things. First of all, we can see, is there a molten core? Is there a liquid core to this fourth planet from the sun? Here on Earth, we have a liquid core. We're a bigger planet. We're still radiating away the heat that left us initially as just nothing but a liquid lump of molten lava. Over time, the Earth's crust solidified. We solidified deeper and deeper and deeper, and we still have a molten core. Well, just like a small pie will, cool off faster than the big one you make to feed everyone at Thanksgiving, a bigger world cools off faster than a smaller world like Mars. Mars has cooled off. It is a world that lacks a significant magnetic field. This seems to indicate that it should be a mostly solid all the way through planet. But we don't know for sure. Now, thanks to earthquakes and how they move around different densities and different kinds of material, if there are earthquakes centered at various points on Mars' surface, their waves moving through the planet, called P and S waves, will either deflect and move around and take longer to get to our probe if there's a liquid core, or they will go through the liquid core and change the kind of wave they are with each of the transitions in and out of the liquid core. With different earthquakes in different places, this will allow us to feel out the shape. It's only going to be a beginning, the shape of that lava. In order to do this as thoroughly as we've done it with the planet Earth, you do need to scatter seismographs all over the surface. But this is a start. And the Mars quakes that we're looking to detect actually have multiple possible origins. We know that Mars has ongoing cratering activity, which is a fancy way of saying our solar system is still hitting Mars with rocks. And every time a large enough rock falls from space, crashes into the surface of Mars, a new crater is formed, and the world shakes just a little bit. This new seismic probe, once it gets there on November 26th and gets fully deployed, it will be able to detect these rocks falling from space, hitting Mars and making it shake. So that is the easiest, most confident way that Mars will shake that we have. Now, beyond that, we're also listening for two other kinds of things to happen. Mars doesn't have the plate tectonics like we have on Earth. It doesn't have different plates that are moving side by side, diving under one another and diverging apart. What it does have, however, is ancient and even somewhat modern in the hundreds of thousands of year old volcanoes. And this tells us that there is the potential for there to still be active magma moving through the surface of Mars, moving through the interior of Mars. And just as the massive volcanic eruption that has started in Hawaii was, it was announced with a pair of 5.4 and 6.0 magnitude earthquakes in Hawaii, we know that earthquakes on Mars have the potential, even if they don't trigger eruptions, to be signs of moving magma under the surface of Mars. So if there is magma still moving, it can cause seismic events that, InSight hopes to see or feel, as the case may be. Now, beyond that, we've seen in the past that Mars has vast cracks, vast valleys in its surface. Different things have different physical causes. But over time, as Mars cools off, it's going to contract ever so slightly. Its surface is going to crack open. And this too has the potential to create seismic events. No matter what the source of seismic events after November 26th and time for deployment, InSight is going to be at Mars, ready to detect all those different things. Now, InSight hasn't been traveling alone. Traveling alongside are a pair of, I wouldn't call them can satellites, because they're more the size of a suitcase. Traveling alongside InSight are MarsCo A and B. These are two suitcase-sized satellites that are NASA's way of testing out a whole variety of new technologies that we're hoping to be able to use to explore our solar system. These first two interplanetary tiny missions are testing out technologies. They're going to be flying alongside InSight. They have their own solar arrays, their own electronics to relay communications and information back to Earth. They're testing all of these technologies, and once MarsCo A and B and InSight all get to Mars in November, these two little satellites, these two little suit box sized missions are going to relay information back to Earth about InSight's descent onto the surface of Mars. So this is a fabulous mission all around, unless you were there trying to watch it. And now we stay tuned and hope that, well, thanks to MarsCo A and B, we have even better observations of its landing than we had of its launch. Now, not all news in our solar system is related to this one mission. We can also look out and see that the TESS mission is in the process of continuing its journey to get into what may be one of the weirdest orbits NASA has ever put a spacecraft into. TESS is the Transiting Exoplanet Survey Satellite. It is on a more than 60-day quest to get into just the right orbit, so that even when it's as close to Earth as it'll ever get, it's going to be up above our geosynchronous weather and communication satellites. And when it's at its furthest, it's going out into the quiet dead of space, where it won't be disturbed by any kind of, well, man-made pollution in the electromagnetic spectrum. And while it's out there, it's going to be surveying all the nearest stars, looking for signs of planetary transits. This is when a little tiny planet passes in front of a background star. So here I have an actual meteor. It's going to be looking for planets, not meteors, passing in front of a background star. And when this happens, we're going to do massive amounts of follow-up with telescopes here on the planet Earth, and once it launches, also at the James Webb Space Telescope. Now, the reason I'm bringing this up today, 18 days and 18 hours after TESS's launch, is because just yesterday we got a mission update that the Perigee 2 maneuver, which was another burn of the TESS mission's engines, was fired correctly. It was just a 7-second firing, but this puts TESS on track for its first lunar encounter and means that the mission is still successfully in its way. Gravitational pull and engine fire after gravitational pull and engine fire, working on getting itself into just the right elliptical orbit so that these planetary searches can begin. Now, more in planetary news, because it seems like we can't go even one day without new and exciting facts, figures, discoveries coming from our exoplanet science teams. We have two interesting discoveries, neither of which this picture has anything to do with. I'm just showing you a cool artist's rendition because I can. Now, unfortunately, I'm showing you this because we don't yet have cool direct images of exoplanets, but we are getting to the point that we can start to use the chemistry of these worlds to help us figure out what's going on their surface, in their atmospheres, and exactly what is their formation. Now, a group of scientists who are out studying WASP 96b, they were able to figure out that this particular world appears to have no clouds. When we look at Jupiter, which is a gas giant planet, we see storms, we see white storms and red storms. The white storms actually appear to be frozen ammonia, water ice in some cases. And this is one kind of cloud formation. On Saturn, as we go from one season to the next, as we flip from summer in the north to summer in the south, we see clouds forming in its atmosphere. Now, it has been theorized that if you take a gas giant planet and you put it very close to its sun so that it has a greatly heated up atmosphere, it may be possible to detect strong sulfur lines in the atmosphere that are indicative of there being none of these clouds present. And with 96b, with work that was done at the University of Exeter, it appears that maybe they finally found that theorized world. They used Europe's 8.2 meter very large telescope, which is in Chile, studied this world in wavelengths that allowed them to see the stars' emission lines and absorption lines, the planet's emission lines and absorption lines, and disentangle this information, allowing them to see exactly what is going on with just the planet. This is a 1300 Kelvin degree planet. This puts it, somewhere between 15 and 1600 degrees. And at these temperatures, this world, which is the mass of Saturn, is bloated up to be 20% bigger than Jupiter. This is a hot, bloated, gaseous world. And there's no clouds. And I just want you to imagine a solid-colored, gassy, broiling world that, unlike Neptune, unlike Uranus, unlike anything we've seen so far, just has a pristine surface with strong sulfur lines. Now, that may not seem like the coolest thing, but it's always good when a theorist has their theory confirmed. This is, after all, how Nobel Prizes come into being. Not that I think a cloudless planet is going to lead to a Nobel Prize. But this is not the only cool thing coming out of exoplanet science this week. Coming up as well is another discovery of another WASP planet. In this case, it's 107b. It was observed by the Hubble Space Telescope. And what they were doing was trying to confirm that our understanding of what planetary atmospheres should be made of. Quick correction to the person in chat, Phoenix. 1500 Kelvin can't be less in Celsius than it is in Kelvin, unless you put a minus sign there. Anyways, moving on. So WASP 107b is a low-density world. It is also a hot Jupiter. It is bloated out. And using the Wide Field Camera 3 on the Hubble Space Telescope, they studied its atmosphere looking for spectral signatures characteristic of the second most common atom in the universe being common in this particular planet. And they found it. What they found was helium. We now have confirmation that, just like we see hydrogen and helium in the gas giants here in our solar system, there is indeed helium in the atmospheres of alien planets as well. Now, in this case, the reason we were able to make this detection was because the atmosphere is so bloated up from the heat of its star. So it turns out one of the tricks to being able to measure this stuff is to heat the planet up, get its atmosphere nice and warm, and look to see what emission lines and absorption lines are there to be observed. So this was a quick roundup of news for today, May 7th. This is The Daily Space. I am your host, Dr. Pamela Gay. Now, these episodes are going to be getting archived on the YouTube channel for CosmoQuest. And if you like them, if you like what you just saw, I'd ask that you please give us a follow. This project is funded through your donations to CosmoQuest, through bits, through subscriptions, and we hope that we're going to be able to keep bringing this to you on a regular basis, like every Monday through Friday from here on out. So thank you for joining, and I'm now going to scroll through the chat and see what questions you have waiting to be answered. Thanks. Okay, so let's see what questions you all had. And I'm going to switch over to the other view. Let's see how this works. I think I have line wrap working correctly in the chat, and that makes me happy. Okay. So thank you all, and I want to know, do you like this new show? Is this the thing you want to see? I see a woo from Lucrux. So glad that you liked this. Okay. Can people at me your questions? Yes, you aren't supposed to ask questions. I'm saying if you have questions, I will answer them. Oh man, I'm so glad that you liked this. So I'm going to be trying to do this every day. Not every day is going to run 20 minutes. We had a lot to talk about. Some days are, some days will be shorter, but this is going to be coming to you pretty much every day. So do you guys have any questions, or do you just have enthusiasm with exclamation marks? Again, it's easier if you at me with these things. Oh, crud, you're right, our Instro. I did math in my head backwards. Thank you. I totally goofed that. Paranord's going to make new Nightbot commands. So why don't we set up a daily space channel over on the weekly space hangout chat channel for now. And we're going to be working on putting together a Discord channel just for CosmoQuest. That's probably going to happen tomorrow. And then we will have a place where everyone here on Twitch can be a part of supporting this, and I will keep monitoring both our wonderful friends and the community that is the Weekly Space Hangout, while having a more open space for anyone that feels like joining. Okay, so sorry for derailing CosmoQuest, but many unit converters were showing. Yeah, I totally did that wrong in my head. Thank you so much. Guido, I'm glad this is a good time. I'm trying to make sure that we have a mix of content for all of our friends that are both in the Asia Pacific region of the world and in the Europe African regions of the world. So yeah, Noel is asking, was there anything in the news about the brute force escape burns insight made? Not so much. I may take that on as a special thing to talk about in a blog post or something. Let me think about where I can do it. So welcome, Inertia TV viewers. You have stumbled into the question and answer period of the new daily space, daily news show we're going to be having over here on the CosmoQuest X channel on Twitch. Right now, I'm taking questions. Oh, I have a formatting issue. Okay, the screen that I'm currently on, it doesn't have formatting issues. It's the other screen I had that had formatting issues. Paranor, is that correct? If it is, it's easy for me to fix that. I love the piece of popcorn. I can fix that. That's easy to do. So do we have any news questions, science questions? If not, I'm going to take off. Today is actually, for those of you who are following along on the CosmoQuest X channel, we had a bunch of people who were happy to see the semester end this year. We also have some new people who are starting. So to celebrate new beginnings and the start of summer, we're going to be having an office celebration this afternoon, sponsored in part by all of you out there who have been supporting us with bits, which often get turned into food for students. So I'm going to be turning those bits into food for our entire team later today. I'm so glad that you like it. That's awesome. So our instro, all of us have those occasional moments when the class you're in can't be over fast enough, and there's other classes you wish you could just take over and over forever. Yeah. We're not going to use unit conversions like that. High altitude Shrenkov, you are radiation. How much molten core is there left from the Mars magnetic field constraints? Not much. I'm afraid I don't have those exact numbers in front of me, but we're looking at significantly smaller by percentage of what the Earth has. I'm sorry that I don't have the specifics. Other questions? I'm not afraid to say I don't know, but I will answer anything that I can. So tomorrow's episode will be based on what new news, what new journal articles, what new ideas from the folks on the Weekly Space Hangout crew have to suggest. This isn't meant to be as in-depth as what you get with the Weekly Space Hangout, which is hosted by Fraser Kane, Morgan Reinberg, and Kimberly Cartier. This is just a quick roundup. Well, I'm not seeing any more questions coming in, so I'm going to go work on getting our day ready. And thank you all for joining us. And wherever you are in the world, have a fabulous morning, evening, or afternoon. And I will see you tomorrow, same time, same place. Tune in for another episode of The Daily Space. Bye-bye.